Hello everyone, and welcome to the Charles Law simulation. Before starting the simulation, let's get familiar with the variables and how they are controlled and where they are recorded. First of all, we can see the temperature is recorded here and controlled here. Pressure is recorded here. We can add gas using this pump. We can select from either a heavy species or light species. Finally, this little robot is in charge of volume. So let's now add a ruler. We will be using this to approximate volume. Right now, we can see that the ruler is giving us a measurement of 6.6 nanometers. We will record that in our data table as 6.6 liters. Let's now add a pump full of heavy species and start the simulation. Note the motion of the molecules. We're now going to pause the simulation, remove the heavy species, and instead we're going to add 100 particles of the light species. Note the change in the color of the pump. Restarting the sim. Note the change in motion and the change in pressure. How are these factors related? We're now going to pause the sim again, remove the light species, add 100 particles of the heavy species, and before starting the sim, we want to make sure that pressure is kept constant. Starting the sim. We're at 300 kelvins. And let's get our first volume measurement. Let's now remove some of this heat. And get a second data point. Let's remove more heat. And get another data point. Let's take the simulation down as close to absolute zero as we can go. Note the change in motion. Notice that as we remove heat, after a certain point the volume stops changing. This is because even though kinetic molecular theory assumes that these particles are point masses, in fact they do have a volume. We are now at absolute zero, and kinetic energy of the particles is effectively zero. Let's now add some heat. Notice that it takes quite a bit of heat to get the molecules at a pressure sufficient to cause a change in volume. There we go. So now we're essentially back where we started. Let's try to get a couple more data points. There we go. And let's try to get our last data point. There we go. Now what happens if we try to continue heating beyond the point that the volume can expand? Let's see. Notice that the pressure is no longer constant. And eventually we exceed the ability of the container to contain our sample. Okay, that's it. This is the Charles Law simulation. Thank you for watching, and don't forget to complete your worksheet and turn it in. Bye.